Now, an arithmetic sequence is a specific type of sequence. The difference between consecutive terms is constant. Difference meaning that you have subtracted the two terms and you find the same exact number happening over and over and over. In fact, the one we just did had that. The same number over and over was the 2. All right? That difference between the terms is called the common difference. So if I were to take, we had 2, 4, 6, 8, right? If I were to take the second term and subtract the first term, we would have gotten 2. And that is the pattern that you saw all the way through that sequence. The common difference of that one would have been 2. All right? It would have been 2. If that number changes, it is not an arithmetic sequence. If it is constant, it is an arithmetic sequence. If it is not constant, it is not. All right? So let's look at this one. 4 minus 2 is 2, right? So right here, my difference is 2. But here, my difference is 4. Here, my difference is 8. Do I have a sequence? Yes, I do. But what is happening? It's growing. So I'm technically multiplying by 2 here, correct? All right? This is not an arithmetic sequence. It is a sequence, but it is not arithmetic. In order for it to be arithmetic, the difference between your numbers must be constant. It must be constant. All right? So let's look at these down below. We're just going to move this guy up. Oh, I already gave you your answers, so we're just good to go. We'll just look at them. 2, 5, 7, and 12. We go 3, 2, 5. That is not an arithmetic sequence, right? But the next one is. Now you'll notice that the difference is negative. Your common difference can be negative. It just means it's going down. Often you'll say I'm subtracting, but for arithmetic sequences, we always base it off of you're adding something, all right? So for here, 48 to 45 is going down by 3. 45 to 42 is going down by 3. 42 to 39 is going down by 3. This is an arithmetic sequence, all right? So we would say, yes, this is an arithmetic sequence. My common difference then would be a negative 3, all right? Negative 3. That is what you add from one term to the next to get there, all right? My common difference is a negative 3. And so for arithmetic sequences, you're looking, am I adding the same exact number? If that is yes, it is arithmetic. It's a specific type of sequence. And then whatever that number is called your common difference, all right? So let's look at the recursive formulas here. 2 types of formulas. We've talked about what recursive means. For any arithmetic sequence, your recursive formula is going to be exactly the same. If I want to find a specific term, a sub n, I can look at the term in front of it and I can add the common difference. For every single arithmetic sequence, that will be your recursive formula. So what happens with explicit? Explicit means that I don't have to go looking for it, all right? So explicit formula says, you know what? I don't need the term in front of it. I just need the first term and I need the common difference. Once I have that, I can find any term in the sequence without having to walk to it. That is the explicit formula, all right? Explicit. Why does this work? So let's talk about this. In fact, I am going to use our 2, 4, 6, 8 formula to generate this guy. Let's move this up. So remember our formula from the section before was 2, 4, 6, 8. All right? And it kept going. We have a little ellipsis there. What's my common difference here? 2. So recursive, of course, is going to look like this. A sub n equals the guy in front of it plus 2. But remember I said that's great and all unless I want the 142nd term. And then I'm not going to sit here all day and do this, okay? So what is technically happening? Well, I start out here. Everybody agree? I start out my first term. We have to. All right? I have added my common difference how many times right here? How many times have I added my common difference to my first term? None, right? So for my first term, and I'm going to erase him because he's going to be in my way. For my first term, I have taken my first term and I have added my common difference 0 times. Everybody agree with that? All right, good to go. All right, my second term. All right, so this is my second term. How many times have I added my common difference to my first term here? Once. So I've added my common difference one time. For my third term, how many times have I added my common difference? Twice. You should see a pattern between the term that you're on and how many times you've added your common difference. What is it? It's one less, right? This is where we get this formula. For your explicit formula for an arithmetic series, it's always going to be the same thing. Always for an arithmetic sequence. You start at your first term, and you add your common difference exactly one less than the term you're looking for. So let's take this guy, all right? This is my fourth term, right? Fourth term. We good to go? So this is saying then, I should be able to take my first term, and I should be able to add one less than the number of terms that I'm looking for. In this case, I am looking for my fourth term. My first term is what? What's my first term? No, my first term, a sub 1 is 2. All right. Which term am I looking for? 4. So I'm going to say 4 minus 1, 3. And what is my common difference here between these guys? 2. What do I get? 8. So if I wanted my 142nd term, what would I do? Well, recursive would be a pain, right? Explicit here, though, I'm going to say 2 plus 141 times 2. And that would be my 142nd term. That's explicit. That's the difference between recursive and explicit. Recursive requires the term in front of it to find the term you're looking for. Explicit said, hey, all I need is the first term in that common difference, and I can give you any term in the sequence. All right? Makes sense? So let's try example 2 here. Suppose you participate in a bike-a-thon for charity. The charity starts with 1,100 in donations. What do you think they just told you there if it said it starts with 1,100 in donations? They just gave us the first term, right? Starts with. Each participant must raise at least $35 in pledges with a minimum amount of money raised. What is the minimum amount of money raised if there are 75 participants? So for every participant, we're adding how much money? $35. What did they give us there? The common difference, right? So they gave us our starting number, right? A sub 1. So $1,100 is my A sub 1. All right? What term are we looking for? Which term are we looking for? We're looking for 75 terms. Now, here's the tricky part. We're looking for 75 additional terms. Do you agree with that? Yeah. They gave us my first term, didn't they? Yeah. It starts with 1,100. They want 75 participants on top of that. So technically, which term am I looking for? 76. The 76th term. So this is what we're trying to find here. All right, so A sub 76. All right. So then I need my n minus 1. So what is my n minus 1 here? If I'm looking for the 76th term, what's my n minus 1? 75. And then they gave me my common difference. Each person is going to bring in $35. All right. So what's the minimum? If you multiply that out, 35 and 75 and add 1,100, you should get $3,725. Everybody see that? Much better than taking that and adding 35 times. Which logically you would be able to figure this out, would you not? Like if I just gave you this without setting up a sequence, you should say, oh, well, 75 times 35 plus 1,100. It makes sense, all right? But now we're going to start looking at patterns.
So we have to still write out that
explicit formula here. So if I ask you for your explicit formula would actually look like this. You would say to find any a sub n, you start with 1,100 plus n minus 1 times 35. And I actually write the 35 here. And specifically, when you do an explicit formula, you typically simplify it. All right, so this is not simplified, is it not? Everybody see that's not simplified? Mm-hmm. How would I simplify this? How would I simplify that formula? So that all I have to do is plug in an answer. Distribute and then combine like terms. So your explicit formula is actually going to do this. We're going to have 1100 plus 35n minus 35. What am I going to do there? Subtract my 35. And I actually usually start with this guy. So my explicit formula is going to be 35n equals 65. That is my explicit formula for a sub n for this guy. And then basically I just plug my n into my formula and I find what it is. So if I had 100 participants, I could, that's plus. I could plug in 100 and add it to the 1065 and I would get how much 100 participants would fall in.
So we have to do it that way. Like we have to simplify that.
Right, so typically I'm going to say, give me the explicit formula, then tell me what the 76th term is. That's what I would do in my particular. So for this, I would say, give me the explicit formula, and then tell me how much money is raised for 75 participants. All right? That would be a question. I would give you a sequence. I would ask for the explicit formula, and then I would ask for the sequence itself, which is what this is doing. So look at B. Use the explicit formula to find the 25th term in this sequence. So go ahead and try that. Use that sequence, write an explicit formula for it, and then find the 25th term by plugging in your 25 into your sequence. All right? All right, this is a term that means, what you learned in like 6th grade with mean, median, and mode. The arithmetic mean of any two numbers is the average of the two numbers. Add them and divide by 2. So for any three sequential terms in an arithmetic sequence, the middle term is the arithmetic mean of the first and third terms. So they give you the sequence here, a sub 1, a sub 2. Literally, add and divide by 2. It's not that hard. What it helps you do is it helps you find a missing term without knowing anything else. So if you look at this example, find the missing term. Key fact here is they told you it was an arithmetic sequence. They told you, hey, you're adding the same number to get from one to the other. If they just called it a sequence, you couldn't use this. This is only for arithmetic sequence, right? So for an arithmetic sequence, if you are just missing one term in between, then you can take these two terms, add them up and divide, and you'll get the guy in the center. Why does that work? Well, I'm adding the same number. So the guy in the center should be the same distance away from the two guys on the end. They just told me it was an arithmetic sequence. And so, yes, this is as simple as this, 84 plus 110 divided by 2. So my missing term is 97. Now that I know that, and actually I could have done this ahead of time, I could have subtracted the 2 and divided to figure out what my common difference was. Now that I have this guy, I can see what my common difference is. 13, right? So I know my common difference as well. I can write my explicit formula. I can do a lot of things at this point, now that I just know any two terms and how far apart they are. All right, makes sense? Easy enough?